Hello friends, welcome. Today we are going to learn the method of 3D interpolation, which is extremely useful in civil engineering, especially when the survey points are considered. So today we are going to learn its concept, then we will go to how to use the 3D interpolation in Excel using some simple add-ins. Then we will use it in finding the approximate elevation for unknown data from our survey, and at last we will talk about its limitations. So let's get started. First, we'll try to understand the concept of 3D interpolation using the 3D model. So let's consider this triangle as a plane. It consists of 3 points. You can visualize the plane like this. So let's consider this as x-axis, this as y-axis, and this blue line as z-axis. So what you can see is there is a line coming out from this xy plane from this position. So if we are saying the interpolation of this point over these 3 points, then what we are doing is we are extending this perpendicular line from this point to z-axis such that the intersecting point of this line and the plane, this point is the intersecting point, and hence we can find out the value for the elevation, which is 0.6. So that is called the 3D interpolation. We have got x, y, z for these 3 points, and we have got x and y only for this point, and we don't know the value for z. So by interpolation, after interpolation, we can find the value of z as 0.6. But how to calculate using coordinate system? So I have already made a function, or which is called the Excel add-ins in Excel, so you can easily download it from the link given in the description. So let's go to how to use the Excel add-in here. So in Excel there is not an inbuilt formula for the interpolation in 3D. For example, if you type here interpolation, there is not a function at all, so you can use the add-in. First, what you do is you go to the developer tab and click on Excel add-ins. If you do not have developer tab in Excel, you can go to file, go to options, then go to customize ribbon and check on the developer button. Since I already have got the developer options, I can easily go to Excel add-ins, and then you can see the add-ins available. So we are going to add a new add-in. So we are going to browse. I have already made the add-in. This is add-in 3D interpolate. So I have kept it in the desktop, so we can use this location as the add-in. But what my recommendation is, do not keep this add-in in the desktop because there is a chances of misplacing it or deleting it. So the better idea would be just go to browse, and while you press the browse button, the Excel already lets you go to the location where the default add-ins are located. For instance, the default location for Excel add-ins are app data, roaming, Microsoft add-ins. So it's always better to keep the add-ins in this location. So what you do is you go to desktop, copy this file which you have downloaded from the Google Drive, just copy it, and again go to browse and paste it over here. So now you have this add-in in the default location where the add-ins are placed, so it will be secured for long term. So after adding this, we can press OK, then it will appear in this dialog box. Ensure that the checkbox is checked and press on OK. After this, the interpolate 3D function has been installed on this Excel. Then if you press equals, then INTER, the interpolate 3D function will be appear. So let's try to do the 3D interpolation in these coordinates. These coordinates are nothing but I have taken this from this model. For example, this point is 1.8, 2.70, this point is 5.8, 6 and 0, and this point is 1.84.4 and 1.4, and we are going to interpolate this coordinate, that is 3.2 and 4.6. So as a result we should get a result z equals 0.6. so let's try here, equals to interpolate 3D. It's already here, so click on this. Now it does not have parameter as an intelligence list, so the better option is to click on fx button over here so that it will give you the arguments to enter. So first you need to enter the value for x, which is 3.2 in our case, which is 3.2 from our case from this point, and for y it is 4.6, which is this y coordinate, and for xyz it is asking for the three coordinates xyz as 3 points, so we are going to include this array. So press on OK, then it will find the value as 0.613, which is almost equal to 0.6. Since this is the approximate value, so it is giving the right result. But what if you have more than 3 coordinates? Yes, you can still apply this result. For example, we say as 10 comma 10 comma 10. Let's say this is the another coordinate, and suppose we have other coordinates as well. For this also we can apply the same principle like interpolate 3D, and in x and y these are the same points, but in xyz you can include all these coordinates and press OK. So among the 3 points it finds the point at which this line intersects the plane. But what if there are more than 3 points? What it does is it finds the nearest 3 coordinates from this point. For example, if we are looking from the top like this, for this point the nearest 3 points will be these 3 points, so it will interpolate the value assuming these 3 points are the nearest point. So it is also called the nearest neighbor algorithm for interpolation. Now we are going to take a real example of the field of survey data, and we are going to try to estimate the value for elevation from the given data. Suppose I have got survey data from the field such that these are the points, and these given in purple color is the elevation, and after survey some points were there. For example, this is the white line is showing the alignment, and what is present is we don't actually know the elevation of these points. For example, this is unknown 29, it does not have elevation over here, and for this point also it does not have elevation, but the points near it has got elevation of like 793.033 and so on. So what we can see from here is if we can find the nearest 3 points from this point, then we can interpolate the elevation value for these each points. So these all points are given in Excel. So the initial points from 1 to 6,800, 3 points are given. These are the survey data, and on the right side I have got some 34 points such that they represent the alignment, these points represented by the white line, for which we are going to find the elevation over here. So let's apply the same rule over here. So we don't know the elevation of these data, so we are going to apply the same function of interpolate 3D, then using this insert function. So we are interpolating x, so for this point x will be this point, y will be the upper point, and for x, y, z we are going to consider this x, y and z because these are the known points, and we are selecting all these 6,803 coordinates. But since these data are always constant, so we are going to press F4 button such that $sign will appear so that the value does not change. So we press F4 button here also, so this will be the function. Now if we press double click on this plus symbol, it will interpolate all the elevation for all these points. So we have only interpolated for this point, and similarly we will interpolate for other points also. So we have got the elevation of these alignments also. Now the meaning is that we have found the elevation of these unknown points. Now what I do is I take these points, press the command select similar, then it will select all those points having no elevation at all. So I'm going to delete these points. Now I will again bring back those points to AutoCAD. For example, I'm using SWDTM for importing these points because in previous we don't have the elevation for these points. Let's go to Excel, select these points in this order having 1 2 3 4 5 columns and select all those coordinates, click on points and then import points from Excel and 0.5 and import points. So it will import points to Excel. Now you can see that the elevation is updated in AutoCAD. Now let's cross check whether the elevation such found is reliable or not. So let's do the case study for unknown point 20. According to the algorithm or according to the Excel add-in, we have already talked that the interpolation is done by taking the three nearest points. So the three nearest point from this point is this point, this point, and this point. So it will make a plane like this and it will interpolate this elevation to this point. So according to the elevation also, you can see this is 796.805, this is 796.283, this is 796.885, and it's 796.907. Yes, you can see that the elevation is increasing towards the lower direction, so it must be higher than 796.8, so it's correct. For other also it does the same calculation. For example, here is 799. The elevation here is 795.425, here is 795.121, and it's almost in between them, that is 795.308. So in this way, if the elevation points of the nearest points are known from survey, we can find out the elevation of the unknown points by using this method. Now let's go to the limitation. Let's see for this point, unknown point 29. According to our theory, the nearest point for this point are these 3 points. So according to the algorithm, it will make a plane joining these 3 lines and interpolate the elevation. So according to here, the elevation found is 802 and the nearest point's elevation is almost around in 793, 793, 792. So it seems that it is rather unrealistic. But looking in deep, it's actually the correct interpolation. So what you need to understand is, let's see this line. The elevation here is 792 and elevation here is 793. Then the elevation of the middle point must be around 792 and 793. But the elevation of the upper point is 793.6. So the elevation of this top point is higher than elevation of this point. According to interpolation, if this point has higher elevation than this point, then the slope is increasing upward. So if the triangle so formed is quite narrow, then there can be a drastic change in elevation while going in longer distances. So if there is a small increase in slope within this distance, then if we are going to this point, then there will be a vast difference in elevation. So it came to be 802.913. But if we look at other nearest points, it's around 796, 795 and 793. So in practical it may not be correct, so there is also a need of manual checking after calculating these points. So that's the limitation for this method. So as a conclusion, we can say that this method is quite reliable if you are not going to find out the precise coordinates or precise elevation. For precise finding of the coordinates, you must do a survey, but if it is not in the, if the survey is not needed in precision, for example for small pre-feasibility projects, you can use this method to find out the elevation, because finding elevation manually is quite a tiresome work, so you can use this method. So thanks for watching.